Hi class, in this video we're going to be using a constant of proportionality in order to generate some equivalent ratios. So recall that for a constant of proportionality, it's going to be represented with the letter k. How it works is like this. Let's say I have a ratio that is a to b. What ends up happening is I'm going to end up with an equation where it's going to be a equals to k times b. So how that works is for a ratio, the entity on the left-hand side is going to be by itself, and the entity on the right-hand side will be multiplied by k. But notice that a equals to k times b is just an equation, a one-step equation. So if I divide both sides by b, I'm going to get k by itself. And in that case, I'm going to get k equals to a divided by b. Now looking at this here, a is just in a ratio, my entity on the left-hand side, and b is the entity on the right-hand side, so k just equals to a divided by b. So if I had 2:5 or 2 to 5 as a ratio, k would just be equal to 2 divided by 5 or 2 over 5. Okay, great. So now that I have the k value, here's what I can actually do. When I have this equation here, I know what k is. I don't know what a and b is. Okay, so let's say I have a equals to 2 over 5 times b. So I have something like this. Essentially, I'm going to let b be any value. So in this case, let b be equal to 20. Okay, great. So if I let b be equal to 20, what I'm going to do is I'm going to have a equal to 2 over 5 multiplied by 20. Now recall, if you do 2 over 5 times 20, you end up just having 2 over 5 times 20 over 1. Then you can just multiply these fractions top to top, bottom by bottom. That's going to get you a equals to 40 over 5, which in this case is going to get you a equals to 8. So hence, if b is 20, a equals to 8. So my equivalent fraction would be 8 to 20. Okay, great. So that's how we can find equivalent fractions. We can just take our constant of proportionality, create this equation, and whatever value of b you want to use, you just pick it. In this case, I just let b be equal to 20, and then I just times it by my constant of proportionality, and that got me an answer for a. Hence, this would be my equivalent fraction here. Okay, great. Now for b, it is going to be 5 to 2. So my k value is going to be, so the numerator is going to be the ratio on the left-hand side, and the denominator will be the one on the right. So I got 5 over 2. And in this case, 5 over 2, or 5 divided by 2, is just 2.5. Okay, great. Now in this case, a equals to 2.5 multiplied by b. So in this case, I'm going to let b be any value. How about we let b be equal to 10? Okay, if b equals to 10, now I'm going to have a equals to 2.5 multiplied by 10. And in this case, 2.5 times 10 is just 25. So a would just be equal to 25. So that means for a to b, 25 to 10 would be an equivalent ratio that I'm going to have. Notice how the k value for 2 to 5 as a ratio is much different compared to the k value for 5 to 2. But regardless, when we apply the constant of proportionality into our equations, we're going to get equivalent ratios. And just to kind of show you what I mean as well, once you get your new equivalent ratio, you can find the k value, which in this case is 8 over 20, which is equivalent to 2 over 5. And you can just prove that since the constant of proportionality are the same, that they are also equivalent via that method.